So we've got this particle which is of mass 10 kilograms. Its initial velocity is u, it's being projected up. We've got gravity heading down. We've also got this resistance, v squared on 10 heading down. So if we look at our acceleration equation, we've got g in the other direction. We've also got v squared on, and this is in newtons, so we know this is mass times acceleration, so I have to divide by the mass, which is 10. So it was v squared on 10, but I've got to divide by 10. There we go. So now it's all as the acceleration. So because I want to look at the particle takes this much time to reach A from O, A being the point A vertically above O is the highest point reached before it starts to fall to the ground, so we know that the velocity is 0 at that point. So we know we want dv dt. So let's go for dv dt, and gravity is 10. So let's make a common denominator. So actually that's 1,000. Let's tip it upside down. So let's put minus 100 out the front. We've got 1,000 plus a v squared. And that's all we've got. I could put my dv up there. There we go. So we know it's going to be a inverse tan. So we're going to have v on the square root of 1,000. So I need the square root of 1,000 out the front as well. And I'm going to make this a definite integral. So we started at velocity of u and we're going right up to a, which is where it turns around. So it's got velocity of 0. All right. So here we've got 100. We're going to have 10 root 10 if I simplify that third. I'm going to ignore that negative, well not ignore it, I'm going to change the limits. So we're going to sub in u first, so I have inverse tan of u on, that also is 10 root 10, minus inverse tan of 0. Alright, so you can see here we've got, if I times by root 10 and root 10 to rationalise that denominator, that's going to be a root 10. We know inverse tan of 0, can't see it here, inverse tan of 0 is 0, so we've just got inverse tan of u on 10 root 10, which is what we're looking at. Alright, so if we want the maximum height, remember that occurs when velocity equals 0. So what we can do there, if I go back, if I cheat, go back to here, there we go, and get rid of some of this, is change it to v to v, whoops, oh well, here we go, v to v dx. Alright, so again, remembering we made this 1,000 so that we could have a common denominator of 100. There we go. Alright, so again, tipping it upside down, we're putting that minus 100 out the front. We're going to have our 1,000 plus v squared on the bottom. And this time, because it's v to v dx, we're going to have a v on top. And you can see that I really want a 2 in order to have a log, so I have to divide that by 2. And the other thing is my limits. Again, I'm going from initial velocity of u up to a velocity of 0. Alright, at the top. So here we've got a minus 50, and this time we've got a log v on, sorry, a log of, what is it, 1,000 plus v squared. And we're going from u up to 0. Again, I'm going to switch the limits and do sub in u first, and then I don't have to worry about the negative out the front. So when I sub in u, I have 1,000 plus u squared, and using my log laws now I put 0 in, and I've got log 1,000. And that's our answer in meters. So that's the displacement it goes through to meet its, to go to its maximum height. Alright, so now it says let W be the velocity of the particle when it returns to O and show that W squared equals blah, blah, blah. Alright, so now it's heading downwards. So if we look at a new acceleration equation, Now, let's say gravity is going down, so let's say 10 is now positive for gravity, but we've still got the resistance. So we've still got that negative v squared on 100. Doesn't matter which direction we're going, that'll always be negative. All right, so if we go for v to v dx, because I'm interested in velocity, and I already know the displacement, even though it's coming the other way. So we have 1,000 minus v squared on 100. So I've got x equals, so I'm going to put the 100 out the front. I've got 1,000 minus v squared on v to v. I need a minus 2, so there's a minus 2 again. So very similar to what we have just done, if not same. All right, so we're going to have a minus this time, where the minus is coming from this inside part. So we've got the minus 50, we've got log, we've got 1,000 minus v squared here going on. All right, so this time what are our limits? We're going from 0 because we're right at that maximum point, so from 0, and it says that the velocity is w when it returns, so it's going all the way up to a w, so from 0 up to a w. So again, if what color am I? Green. All right, so if I swap out and make that 50 swap limits, we've got the 0 first, so that's going to just be 1,000, and then we've got the w second. All right, so that's what we've got, and what we're saying is that x has to be the same distance as this here, so we'll just put that there, so that has to equal that. All right, so let's have a look, and what we really want to do is just make the w the subject. So they both got 50, nice, they both got log, so we'll ignore that as well. They don't both have, but let's start with this 1,000 plus u squared will equal, yeah, why don't I do that at the same time? Doesn't matter. All right, so we're going to make this, all I'm doing is timesing the 1,000 across. Actually, at the same time, I'm going to divide by that one and instead times this one up here. All right, so I've times that one up to the other side, and I've times that one up to the other side, and we've divided both sides by that one. So this is what we've got at the moment. You can see it kind of looks close. If I put the w squared on that side, and so I'm subtracting this one, I'm going to make a common denominator. All right, so really I'm doing 1,000 minus that 1,000 squared on blah, 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 blah. So what am I going to have here? I'm going to have, actually, to make it a common denominator, 1,000 squared plus 1,000 u squareds. And then I'm also subtracting 1,000 squared. All right, so just make sure you follow that through carefully. So what I'm getting is w squared is 1,000 u squared on 1,000 plus u squared, and we're hoping that's what we wanted. 1,000 u squared on 1,000 plus u squared. Excellent.